Good morning. So today we have to discuss the next topic, which is the fundamental theorem of calculus, part 2. It's a relatively simple idea. For example, what if I said take the integral from 1 to x of 12 t to the 5th dt? Well, we would just integrate this and get t to the 6th, divide 12 by 6, and we get 2. And then we have to evaluate it from 1 to x. So now we would plug in x and get 2x to the 6th minus 2. Well, now let's say I wanted to take the derivative of this. If I take the derivative of this, you then get 12x to the 5th minus 0. So in other words, all I really did here was this. I took the derivative with respect to x of the integral of 1 to x of 12t to the 5th dt. In some ways, it should be pretty obvious. Well, the derivative is the opposite of taking the integral in most ways. Therefore, they basically cancel each other out. And therefore, you're left with the same answer as you have. The only difference is the change of variables. This was with respect to t. This is now with respect to x. And the reason that occurs is this top limit gets plugged in and on this step here, giving you the x value, and therefore the change in variables. So what the fundamental theorem of calculus part 2 says is the following. It says if f is continuous on AB, and again that has to be the case to take the integral, and f of x is equal to the integral from any number to x of f of t, then f prime of x is equal to the derivative of the integral from a to x of f of t, which then means these cancel out and x gets plugged in during the integral process, f of x. So I'm going to show you 3 examples. This rule is extremely easy, and you'll get extremely comfortable with it because there's really not much going on with it. So let's take example 1 here. The derivative from 1 to x of t squared minus 2t plus 3 dt. Well, again, we don't have to go through this process anymore. This is our shortcut, basically. But if we did it, we would get the integral with respect to t's, and then we would plug in the x's, just like up here, plug in the 1's, and then when we take the derivative, this would just go away anyway, and we'd be left with just basically x terms for the initial function. So in other words, these basically cancel, and just plug this in. So the answer is x squared minus 2x plus 3. In the end, these cancel, you plug in the limit. So now let's spice this up a little bit. What would life be without spice? Let's take the derivative of the integral from 2 to x squared of cosine of t dt. Same thing. These basically cancel, you plug this in. So you get cosine of x squared. But there's a little bit of a catch. The chain rule. If you were to plug this in up here, this would be an inside function. And therefore we must take the derivative of the top limit. And there's our answer. So again, this is the chain rule. And this is just simply the fundamental theorem of calculus part 2. I know what you're thinking, still not spicy enough. Fine by me. Let's take the derivative of the integral from negative x to 5 of natural log of t dt.
Attention, the serial number is located under the barcode on the front of the test booklet. Thank you.
The rule does not apply if the x is on the bottom. So all we can do is switch it. Well, the only way to switch it is to real quickly put a negative out in front to switch the variables. So in other words, we're going to take the negative derivative of the integral from 5 to negative x of natural log of t. And now we can do it. Apply exactly the same thing. You plug this in, we get natural log of negative x. Take the derivative of negative x, you get negative 1. And then of course, don't forget this negative out here. So in other words, we have basically positive natural log of negative x. So the only difference is you have to switch the limits. And to do that, we must make the whole thing negative. So let's do the hardest one I can possibly imagine. Let's take the derivative from 2x to x squared of the square root of t squared plus 1 dt. There's no constant, so we have to make one. So we're going to take this and write it as two different problems. It does not matter what point you split it up as. But I'm going to do, let's say 1. I hate choosing 0 just because it's 0. Let's say I choose 1. The first integral would be the derivative of 2x to 1 on the square root of t squared plus 1 dt, plus the derivative of the integral from 1 to x squared of t squared plus 1. Sorry, I forgot my square root. dt. And now we can handle these problems easy. This cancels. We're left with the square root of x to the 4th plus 1 plus this one we've got to make negative to switch to variables. I know I made a mistake on the other one over there. I'll fix that in 1 second. You plug in 2, you get 4x squared plus 1. So there's the derivatives, but I forgot the chain rules. The chain rule for this one is 2, and the chain rule for this one is 2x. So therefore the answer is negative 2 square root of 4x squared plus 1 plus 2x times the square root of x to the 4th plus 1. So let's do a couple more problems just to kind of make sure we're good with this. Let's find the tangent line. Where f of x equals the integral of 4 to x squared natural log of t cubed plus 4 dt at x equals 2. So first thing, take the derivative. Take the derivative, we get f prime of x equals the chain rule, which is 2x, times natural log of x to the 6th plus 4. So I plugged in x squared, derivative of this is 2x. Let's plug in 2. So we get 4 natural log of 68. So there's my slope. So we know the tangent line is 4 natural log of 68, x minus 2. All we need is this y value. The great thing about the y value is if you plug 2 in, you get 4 to 4. Well, the area from 4 to 4 is going to be 0. So we're done. So the last problem I want to discuss is off the worksheet. It's off of worksheet 5.3, number 1. So the first part of the problem says, take the integrals from 0 to x of this function, where f is a function whose graph is shown. Evaluate g of 0, g of 1, g of 2, g of 3, and g of 6. So part A, G of 0. My suggestion to you is people who do well on these AP problems, and this is not an AP problem, but I can tell you from experience, you will start seeing AP problems like this. The people who do well are the ones who actually write out what they're doing. It's the integral from 0 to 0 of f of t. If the limits are the same, therefore it's just 0. The next one, from 0 to 1. From 0 to 1 there's a horizontal, it's hard to see there, horizontal line there. So from 0 to 1 it's just 2. G of 2, from 0 to 2, the area is, so we have 2 on this first part, the area here is 2 more, but the area on this little triangle up here is length of 1, height of 2, so that is 1. So it's 2 plus 2 plus 1, so 5. For 3, you'd have the integral from 0 to 2, or from 0 to 3, which would be equal to basically 5 plus this last triangle here. The height of this is 1, 2, 3, 4 by 1, so the area is 2, to get 7. And the last one, from 0 to 6, we already did all the way up to 3, so I just have to find the area of this trapezoid here, and that is a base of 1, 2, 3, 4, base of 1, a height of 2, and times that by 1/2. 1/2 the height times base 1 plus base 2, which is 10, 4 plus 1 is 5, times 2 is 10, so 5. And therefore this integral would be 7. This is a negative area, minus 5, which is 2. You can check my work there. It's 1, 2, 3, 4, 1. I just realized this is 6 right here. Oh well, we'll do 0 to 7. On what interval is g increasing? So again, how do you tell if g is increasing? That means the derivative is positive. So let's take the derivative of g. G prime of x is equal to the derivative of the integral, and you can see how, this is the problem I usually give on an AP test here, the derivative of the integral, these cancel, it's just f of x. In other words, this graph over here is the derivative. Therefore, when is it increasing? If we do a sign analysis, 0, 7, it's positive until you get to 1, 2, 3, and then it's negative. Therefore, it's increasing, then decreasing. So the area is increasing to 3 and decreasing afterwards. So it's increasing from 0 to 3. Where does g have a maximum value? You can clearly see it's at 3. So the maximum value is x equals 3. So for homework tonight, and I'll post all the answers on the e-board under the Chapter 5 tab, is worksheet 4-5, numbers 25 to 31 odd, 39, and worksheet 5-3, which is the worksheet we just had that last problem from, number 2, 17 to 37 odd, skip 33 and 35, and number 40. So that should sum up basically what we did in what we would have done in class today. So again, do your homework, check your answers, circle the ones you want to go over on Monday, and we will cover those ones more specifically. Thank you. Enjoy the rest of your day.